Hello, everybody. So, don't mind those noises in the background. I just got just torturing the neighborhood children downstairs. So I got two examples I want to go through. And please, 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 I hope you're watching this video. If you are, God bless you. So this one, the denominator of a fraction is 2 less than twice the numerator. That's a mouthful. If you add 7 to both the numerator and the denominator, then guess what? That fraction equals 4/5. So what is the value of the original fraction? Okay, so the original fraction has the denominator is 2 less than twice the numerator. So let's just call our numerator x. And that means the denominator is 2 less than twice that. So I have to do 2x minus 2. And then it says, guys, I'm recording. I'm working, so please go downstairs. And then if you add 7 to both the numerator and the denominator, then the fraction equals 4/5. So I'm going to add 7 to the numerator. I'm going to add 7 to the denominator. And that looks, of course, just like that. And if you do that, the fraction equals 4/5, which is what that is. Well, -2 plus 7, those are like terms. I can combine them to get 5. And then I really want to solve for x. So you got two fractions. You've got an equal sign. You can do whatever you want. So you solve for x. Please solve for x right now. Well, I very much hope you did. And if you multiply both sides by 2x plus 5, 2x plus 5 will cancel out. And you'll end up with 4 times 2x plus 5. And then you also multiply both sides by 5. So here the 5 cancels out, and then this becomes 5 times x plus 7. Distribute, and I subtracted the 8x from both sides. That got me -3x. I subtracted 35. That got me -15. And I discovered that x equals 5. So what? That is not the final answer. Remember, what was the original fraction? So the x value is 5, so the numerator is 5. The denominator, remember, was 2 less than twice the fraction, twice the numerator. So if you double 5, you get 10, and 10 minus 2 is 8. So the original fraction was 5/8. Second and last example. So Vicky has scored these scores on her last 4 quizzes. To have a quiz average of 85, or I should say at least 85, that's what I really want to say. What's the least score she needs to get on her 5th quiz? So we're going to assume it's out of 100. So these are all percentages. So these 4 are her percentages from her first 4 quizzes. I could just find the average very quickly. You add them all up. You divide by how many there are. So the average of her first 4 quizzes is 81.75. She wants 85%. So she's going to have to do very well on this 5th quiz. She has to bring up her average 3.25 points. So how do you take the average of 5 quizzes when you only know 4 data points? Well, when you don't know something, we would just call it x. We're going to let x represent the 5th quiz, the score of the 5th quiz. So now look at this numerator. You're adding 5 data points, so you must divide by 5. You're not dividing by 4 anymore. You're taking the average of 5 things. And you want the average of those 5 things to be at least 85. So these 4 terms are all like terms. I can add them all up, and I get 327. And I want to solve for x. So you try again. How are you going to get x by itself? You got to do 2 things. You have to get rid of the division by 5. You have to get rid of adding 327. So find x, please. Well, you should multiply both sides by 5, and you're multiplying by +5, so you don't have to flip this sign. It's still greater than or equal to. And 85 times 5 is 425. Subtract 327, and you get this. What does this mean? What does this mean? That is, remember, x represented Vicky's 5th quiz. So Vicky has to get at least 98 on her 5th quiz. And if she does that, her quiz average will be at least 85. X represents her quiz. That quiz has to be bigger than or equal to 98. and she will have her desired 85 quiz average.